When a data provider wants to contribute its data to the euBusinessGraph, it should make sure that its data are represented using the semantic RDF graph-based data model and the recommended euBusinessGraph ontology. However, most of data providers have their data represented in a tabular format. To bridge this gap, data must be transformed. The transformation requires the specification of mappings from the input table to the euBusinessGraph ontology, a process that we can also refer to as semantic alignment. However, while transforming the data, the user may also want to enrich the input data, fully exploiting the power of semantic data models used for publishing the euBusinessGraph data. Aligning and enriching the data manually or programmatically can turn into difficult processes. Luckily, we have tools to support these processes and help data providers in contributing their data to the business knowledge graph. DataGraph is an application that helps users transform, host, and access their data. Grafterizer is the DataGraph component that supports generic transformations, including mapping from tables to RDF. In addition to its native functionalities, Grafterizer is now endowed with a tabular annotation interface, which supports semantic alignment and data enrichment in Grafterizer. The tool that fits this tabular annotation interface is named ASIA, which stands for Assisted Semantic Interpretation and Annotation of Tables. ASIA provides several features to work with and fully exploit semantic data models, which are implemented by a configurable set of services and can be easily extended to quickly adapt to new requirements and domains. These services support three main tasks: the semantic alignment of the table to a graph-based schema using existing vocabularies and ontologies, the reconciliation of the values in the table against reference knowledge bases, and the extension of the table using information in third-party sources. For a more complete description of ASIA functionalities, we refer to the web page describing the tool. In the following part of this video, we will show how semantic alignment, reconciliation, and extension functionalities provided by ASIA can be used to support the publication of new data as part of your euBusinessGraph data. In particular, we will focus on a few new functionalities that have been introduced to deal with cross-linguality in this process and to enrich data with LAU codes, which are frequently used in company-related data. The data we are using in this video come from Spaziodati, but have been substantially modified to ensure anonymization and support the demo. Also, we will start assuming that the source data have been already uploaded in DataGraph and are ready to be transformed and enriched. Semantic alignment, reconciliation, and extension functionalities can be applied row by clicking on the icons placed at the side of each header. We start by showing how to align a column to a graph-based data modeling using, preferentially, the vocabulary specified in the euBusinessGraph ontology. While explaining this, we assume that the listener is familiar with RDF and with the usage of vocabularies and ontologies in RDF. To help users with semantic alignment, ASIA can suggest classes, data types, and properties specified in existing vocabulary and used in other RDF data. Vocabulary suggestion services serve this goal and can be configured by clicking on the icon placed at the side of the Update RDF Mapping button. Upon click, a widget opens. The topmost menu lets the user specify the full prefix to be used every time some string, for example a header, must be transformed into a URI. We will use this later. The menu below lets the user select and configure the vocabulary suggestion service. As the full service, we use Abstat. Abstat is an RDF profiling tool that extracts all the schema patterns occurring in a dataset, their frequency, and other interesting statistics. The vocabulary suggestion service based on Abstat uses full-text search on Abstat profiles to retrieve useful suggestions based on the usage of vocabularies in datasets indexed by Abstat. We will be back to discuss this language option in a few seconds. Now that we have checked which vocabulary suggestion service is in use, we can align a column. However, The essence of the alignment process is the specification of which column pairs are in a relationship which we want to represent with triples in the final graph. For example, intuitively, the column with header nome provides the name of the companies whose identifiers are provided in the first ID column. The subjects of the triples that we want to generate will be taken from the first ID column, while the objects will be taken from the second nome column. A triple will be generated for each row. So, how can we specify this in Asia? We can do this by annotating the object column, that is, the column that will provide the objects of the triples. In this case, we will annotate the second column by clicking on the plus icon. Upon click, a widget opens. We need to specify if the values in this column will be transformed into URIs or literals. Then we must specify which is the source column, that is, the column that will provide the subjects of the generated triples. Finally, we must specify an RDF property that will be used as predicate in the generated triples. The user has to specify if the column will be unified or not and the source column. Then, Asia suggests us a suitable property to be used as predicate in the generated triples. However, we can see that the only suggestion is a strange property nomen from the DBpedia ontology. The suggestion is not very useful, but the reason is that we have not configured the suggestion service properly. In fact, we are using the default suggestion service with its default configuration. Asia has matched the Italian word nome against vocabularies that use labels in English. To get better suggestion, we need to make sure that Asia is aware that the language used in the table headers is Italian. Let's close the widget and fix the configuration of the service. While we fix the language, we can also try a different vocabulary suggestion service, LOV. LOV, L-O-V, is another RDF data profiling application that lists the vocabulary used in a large number of public RDF datasets. This time, we also set the dataset language to be Italian. How can we constrain the suggestions so as to prefer vocabularies we are more interested into? Consider that LOV has indexed hundreds of vocabularies. We can use another setting available for the vocabulary suggestion services, the preference between different indexed vocabularies or profiles. In this case, we prefer DBpedia's first vocabulary and FOAF, F-O-A-F, as second vocabulary. Observe that we cannot specify the euBusinessGraph ontology vocabulary in LOV because no dataset that uses this vocabulary has been publicly released and indexed by LOV yet. Let's see if we can find interesting suggestions from these vocabularies though. We open again the alignment icon and we now see that the suggested property is the DBpedia property name. We now have a better suggestion thanks to the cross-lingual matching algorithm implemented in Asia that has first translated the header in English using an automated translation service and then searched in English. However, we are still unsatisfied with the selected property because we could not use properties from the euBusinessGraph ontology yet. Abstract is an open source profiling tool that can be run by the user on any RDF data, and we did run it to profile euBusinessGraph data. In this way, we have collected statistics about the usage of vocabulary in euBusinessGraph data and have indexed types and properties used therein. Here we want to prefer the vocabulary used in two datasets. S.E3 as first preference, because this is the dataset represented using euBusinessGraph ontology, and DBpedia second choice, just in case we need to use predicates and types that are now listed in euBusinessGraph ontology. We now open again the annotation panel and find that the property suggested by Asia is legal name property, a property recommended in euBusinessGraph ontology. Now we specify that this column will provide literal values and Asia suggests using the class string. Finally, we can specify the source column to be the first ID column and click on the Annotate button. Observe that a warning icon appears now at the side of the header. A warning has been issued because we have specified that the source column for the triples generated from the annotated column is the first column with the header ID. However, we have not annotated this column yet, and we have not verified its values, which is required to generate valid RDF triples. Let's do this. If we click on the URI button, we need to specify which will be the namespace used in the URIs. Instead of doing this for each column, we can go back and specify this in the global settings. Now we are ready to verify the column, and we can add a class to the URIs generated from this table. Asia suggests the class identifier, but this is not the best class to use for this column because the URIs generated from it will be the actual identifiers for the company in the graph. We can therefore edit the suggestions by exploiting the autocomplete service powered by Abstract on the available data profiles. With this, we can set registered organization as class, that is, the class used to represent companies in the EW-BusinessGraph ontology. The URIs generated from this column will not be objects in any triples, as they will only play the role of subjects. We can thus remove the property, and we can check that Asia has detected that this will be a subject column only. Now the warning issued when annotating the previous column is disappeared, and we have established the valid alignment for the first two columns. In a real-world task, we can repeat this process for all the columns that we want to include in the graph. However, in the rest of the video, we will show how to apply reconciliation and data extension services to explain how we can perform data enrichment by annotating the table. Let's show now how to use reconciliation services. Asia supports different services that are associated with groups. Here we show how to use Wikifire, a cross-lingual named entity linking service that we wrapped into a service that works with table. Let's see if we can find in the column that lists company names and companies represented in the DBpedia Open Knowledge Graph. To use a reconciliation service on a column, the user must click on the table icon placed at the side of the header. We select the generic group of reconciliation services, which points to services that covers different domains. We select Wikifire. We also check the box that makes sure that the new column that will host the results of the reconciliation is placed next to the column we are reconciling. The service is now processing the values to find matches in DBpedia, ranking candidate matches, assigning them a confidence score. A threshold is used to decide which matches to include. In the preview panel, we see the top match for each value and the confidence score. The user can check the entity in DBpedia. Now we can use the buttons on the right-hand side to decide which matches to persist. We can filter the rows to support this operation. If we select the rows for which no match has been found, we can manually edit the desired match. We can keep on reviewing the matches and click Apply when we are done. In this example, we have persisted only 6 matches. Asia uses the types of the entities to infer the type of the column. We can check the infer alignment annotations by opening the widget. Now we can do the same for the column Provincia, which lists administrative units associated with the companies. We review again the matches and decrease the threshold to increase the number of matches. Now we have found 48 matches automatically, while we still have 4 values that are now reconciled. We can see the infer class. Now we can further align the columns so as to generate triples using the reconciled values. We check the infer class, select the source column, and specify the property. In this case, we cannot find a property from the EW-BusinessGraph ontology, and we use a property from the DBpedia ontology. For reconciling locations, we can use a dedicated service that usually performs better than Wikifire because it reconciles the values against the GeoNames knowledge base, which is specific for location. Also, this service works with different languages. However, for this example, we will keep the results found by Wikifire service and proceed to show data extension services. Now that we have a column with values that are reconciled against entities from a knowledge base, we can use extension services to fetch additional data about these entities. For example, we use an extension service based on same as links to add LAU codes to the data. After clicking on the Extend button, we see the preview of the extended table. We have added LAU codes from some values in the provincia column by using the reconcile entities in DBpedia. If we want to publish also these additional values in the final graph, we need to align this new column by specifying the right property and other information. Let's now assume we are done because we have aligned all the columns we want to publish in the graph-based data model, and we have enriched the data with the desired additional information. We first update the mappings by clicking on the related button. This makes sure that the mappings that are actually used to transform the data in Grafterizers cover all the annotations added with Asia. If needed, we can also review the mappings using the RDF mapping interface. We click on the download button and use another widget to specify the format in which we desire to get the data. In this case, we want the data in the N-triple format, one of the most used RDF formats. More formats are supported though. For example, we can leave the enriched data in CSV format and exploit Asia's data enrichment functionalities without transforming the data into a graph. If we select OK, we can finally download the generated triples. We hope that you have enjoyed this video. For more information about Asia and its features, we recommend to visit its webpage on the euBusinessGraph website, its GitHub page, and our Insights Lab website.